Okay, good morning everyone. Shahin is here. Um, we wait for a couple of minutes and hopefully 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think two more people might still attend. So I am sharing with you the instruction for the lab. Okay, I wish we could make a complete recording, but that is currently unavailable. So here, this is your last experiment. So that I explained to you what this lab is about. So here you can access the instruction document. That's a relatively comprehensive, which tells you about the things you should do. All right, beams are complex structures, relatively complex. And the theory that we are using is a simple theory. There are more sophisticated theory for beam, such as Timoshenko beam, in case if people want to have a more detailed, more accurate analysis. Those analysis can be used. But this is the most simple one. According to that, we assume that the plane remains plane during the bending. If you make a cross section before and then after section, that section won't warp. It remains a plane, even though the curvature changes. So that's simple theory. Generally speaking, in the most general case, a beam would develop three types of internal forces. One being axial, N. Second one being the shearing force. So the shearing force tends to make the beam to shear along the transverse direction. The third internal force has a different nature. That is a bending moment. And the bending moment is mostly responsible for change of the curvature. And either of these internal forces, they cause some kind of internal stress. So why do we need internal stress rather than internal force? That is to make a comparison. So stress is something universal. If I find something with a stress here, that is comparable to the lookup table. Lookup table would tell me about the limit of the material. And then if I give you an example, it's a silly joke. They ask you, is steel stronger than the cotton? And the answer is yes. But then they say, okay, I have a tiny strings of steel, and then I have a thick rope made of cotton. This cotton is stronger than steel. And then you start to think, okay, it's not just a matter of force. That performance has to do with things. First is the geometry. Second is the internal laws. Third is material. So you can make a judgment without having all these three things together. And stress is needed. Internal stress has to be calculated in order for you to make a judgment. You can make judgment only on forces. You say this string can take 10 kilonewton, this copper, this cotton takes 10 ton. So this is stronger than that. No such a thing. If you bring all these things together, you find out that the stress needs to be calculated. All right, in this experiment, it's very simple because shear force is responsible for a specific type of stress we haven't covered yet. Next week, I tell you how the shear force can develop internal stress. All right, that you don't know anything about yet, but what you know is called flexural formula. Flexural formula tells you that, look, internal force moment, Newton meter, that is responsible for a normal stress. So when I start to bend, so the stress which develops in the normal, in the axial direction, that is proportional to the magnitude of the bending moment. So the larger M, the larger stress. It also is a two-dimensional thing. It's not only a function of X axial direction, also that is a function of transverse direction. So different points across section. Here, I'm showing you a cross section. This cross section is called C section. I mean, this is a flipped C. It's not a right C. But you can see that this is a very common type of a structure. And we do the experiment for that section. All right? So when you are calculating the stress direction is projecting out of the plane. That is axial direction. So the x-axis is projecting out of this plane, and the vertical direction we call this transverse. So if my point is sitting at the neutral plane, anyone remember where the neutral plane is? How do I find neutral plane for this section? Anyone remembers? Yes, and then yeah, you need to find the center of area. So the center of area, a plane which passes through the center of area, that is the neutral plane. So why neutral plane is important? Because at the neutral plane there is zero stress. Above it is either tensile, below is under compression. So at the neutral plane the stress is zero. That's why this is the DOTM. This is the reference, and that is different with every cross section. For every cross section, you have to find the neutral plane. Okay? So that is the position of Z. In this experiment, I'm not giving you the position of Z. So the most important calculation you have to do is to find out where your neutral plane is. And then I give you a couple of points at which I have attached the sensors. At these sensors, you are able to measure not a stress, but a strain. So I tell you about the strain later. That is not a part of the curriculum, but that's easy to understand. Okay. Okay. So you want to calculate. So let's limit everything to calculation. I get into the measurement later. With the calculation, flexural formula tells you the normal stress projecting out of this plane for different points. If my point is sitting on the z-axis, on the neutral plane, the stress is zero. If I get farther from z plane, the farther I get, the larger the stress. So if you have to tell me whether this point develops larger stress or this one, numerically, you have to compare this number with that number. This number is larger. Okay, so the points which are sitting on the top, they're farther from the. I mean, if my illustration is correct, maybe my illustration is not out of a scale. If that's it on the scale, and then this is closer to here, my critical point would be the top because it has a larger distance from the neutral plane. So stress is proportional to the bending moment, is proportional to the distance from the neutral plane. The farther, the larger, and reversely proportional to the moment of inertia. So the larger the moment of inertia, the smaller the stress, and that means your structure is under less stress. That's a good thing. So in the design, you don't want your structure to be under stress. To reduce it, you enlarge the moment of inertia. That explains to you why, if you have to choose a timber in the long side or in the flat side, you use it in the long side because long side has a larger bending moment. So in that way, the very same material, wood, goes under less stress with the same amount of the loading. Make sense? Okay. So as far as calculation is concerned, you know how to proceed. First, you have to find the position of neutral plane. And then I give you a table. In this table, all the y dimensions are given with respect to the DOTM. DOTM is the bottom of this C shape. So you have to take that away from the y value. You calculate y value, you take it away, and that tells you the y value which is used inside the flexural formula. Because in the flexural formula, you are not interested how far this point is from bottom. you're interested how far that is from the neutral plane. Okay, so that's very critical step. Make sure you don't miss it. And then I have a number of sensors from 1 to 9. These sensors are positioned into different plates. So how does it make difference? I mean, these positions, they have different x values, right? So remember, bending moment is a function of x. It changes with the axial direction. So bending moment here with bending moment over here is different. But this is a two-dimensional thing. With y, these 2 points have different y's, but this point, that point, they have the same y. All right? So for every point, you not only need to know the x value of the point, also the y value of the point. X value of the point, you compare that with the bending moment diagram, you find the value of the bending. That bending, you plug it inside the flexural formula. Also, you need a y value. For that point, what is the y value? Plug it there. I value, you have to calculate it at the onset. And then you can't do it without knowing the neutral plane. I value is compared to the plane of zero bending. Okay, so that is the calculation. Do you want me to explain again with the calculation? Please don't be shy. If you need, just ask me. I'm happy to explain it again. Okay. All right. So you want to find out the stress, internal stress due to the bending. So the prerequisite for that is you need to know the bending moment at that point. So I want you to find that in few points. These points are distributed in the x and y coordinate system. So you need to know both x and y value for each point. X value would help you when you have the bending moment diagram. Remember, we did the bending moment diagram as a function of x. So by knowing the x with respect to the support point, you are able to calculate the bending moment. What you have to calculate next in the flexural formula. Do you remember flexural formula? That was axial stress is equal to the m multiplied by y divided by I. See, three parameters. M, you get it after knowing the x, right, from the bending moment diagram. Y goes to the numerator. You have to calculate y, comparing this y value with the things here. And I goes to the denominator, right? So x, y, m, I. These are the things you have to calculate. And the calculation would be different for every one of these 9 points. All right, so that is with the calculation. The second part of every experiment, in every experiment, you have an analytical way of estimating things. They are not necessarily accurate. And measurement, hopefully, if that is done correctly, should comply with your estimate. So many things can go wrong. I mean, your hand calculation might be wrong, the signal. And I give you some insight in terms of the measurement. This rig is designed to support a beam in a horizontal configuration. And it was designed to take a couple of different sections, not only C section, also T section, I section, and the box section. And then they were using this for a couple of semesters, and the results were nonsense. Okay, so that was faulty by design. And just I noticed that for that design, we need something like a car, 2 tons, 3 tons, to be suspended in the middle such that you get a meaningful signal, right? So this was done. The only thing I could do was say, oh, forget about the T section, forget about the I section, box section. With the C, we send that to the machining workshop. We get this to be reduced in size. We deliberately make this weaker. Make it weaker because in this room, the maximum load I can apply is, if I want to go for 40 kilograms, 50 kilograms, that is the largest I can go. 50 kilogram gives me 500 newtons. 500 newtons with a aluminum structure, that's marginal for getting a meaningful signal. Anyway, so we did the machining, we remounted the sensors, and now I'm using a pulley. Why am I using a pulley? Because now I only apply 35 kilogram, and 35 kilogram is double. With a pulley, now I can apply 60 kilogram. And then considering the risk of the, so I'm telling you this because these are things you need to know to understand the source of the error. If something is designed faulty, or the sensors, they have a threshold, they have a noise to signal ratio. If the noise is comparable to the signal, the result is not meaningful. Anyway, so I have a very heavy load underneath this table. This is not applied yet. By tightening that screw here, that would lift the heavy object from the table, and when it is lifted, now the beam would feel the load. Before that, now this is unloaded. To make this loaded, I have to either pull away the trolley underneath the weight, or I have to tighten this screw to just shorten the cable, and then bringing this up. When it is up, the load actually applies right in the middle. Okay, so what you need to know is, you need to know the insertion point. This is a point load. That's not a distributed load. Everyone agrees? So we had some teachers here. They were on the notion of making a steel like triangle that's a distributed load put in here. Yes, that is a theoretically correct, but practically that thing is likely 5 kilograms, 10 kilograms. 10 kilograms is not enough to start the signal to say ouch, right? So anyway, with the limitation we have, we only can apply a point load. That point load is applied right in the middle. You know how to calculate it? The weight of that one multiplied by 2. Why multiply by 2? Because you're using a pulley system. The pulley system, tension on both sides are equal. So 2 tensions of equal 35 kilograms, that is something like 70 kilograms. And that is applied right in the middle. So you need to know the length of the beam, where the exertion point is. From here, you can plot a bending moment diagram. So bending moment diagram for every sensor, you can pick up how much bending moment is there, and you can find out their Y value. What else do you need? Okay, so the question, how do we measure? Okay, make sure you watch the recorded, because otherwise you might not be able to complete the lab. Okay, how do we measure stress? I mean, I know how to measure temperature, I know how to measure length, but how do we measure stress? So this is a very tricky question, and many parameters we measure them indirectly, stress included. So if you want to measure density, how do you measure density? There's no way you can measure density. You have to measure the weight, you have to measure the volume. Combining them together, that gives you density. Stress is the same type. So, I mean, if I'm talking about the average stress, yes, I measure the load, I measure the area, but I'm not talking about the average stress. I'm talking about the flexural formula. That's a very, I need to know the stress at a very specific point. So here, we measure the stress indirectly. How can you measure stress indirectly? All right. I know that the first part of the flow curve, anyone knows what the flow curve is? Do you remember in the class I showed you the behavior of material under the loading? It starts with a linear deformation, like a hook, a spring, and then it goes to the nonlinear section. With the linear part, the elongation is proportional to the stress. So we can't measure the stress. We measure the elongation, the percentage of the elongation. Percentage of the elongation is called a strain. A strain doesn't have any unit. This is like a percentage. That is the length changes divided by the initial length. That is called a strain. So here we have a sensor that is called the rosette. Rosette has a rosette shape. This is a resistor. The resistor has some resistive. So once this becomes longer, the resistance becomes larger. So that resistance is proportional to the elongation. So you are measuring the elongation, you are measuring the strain, and then to convert that to the stress, all you need is a proportional factor. The proportional factor is called Young modules. So if you know the Young modules for the aluminum, after measuring the strain, doesn't have any unit. Multiply that strain by the Young modulus that give you the stress. So I repeat my question. How do we measure stress? We measure that indirectly. You measure the elongation strain, multiply that by the Young modulus that give you the stress. All right, we have a data acquisition system here because these rosettes, the signal they produce, they are so tiny, and we need to magnify them before it can be measured. So here there are some electronic boxes. These electronic boxes would change the milliamp or millivolt signal from here amplified. They condition the signal, getting rid of some of the noise, and then all these come through this cable to USB port my laptop. And here I have a data acquisition software which is specifically written for these sensors. So by plugging a point, it starts to get the data. But given the delicateness of the measurement, at the start you are not measuring zero. There might be some trapped signal into the wire. So you need to measure everything before the loading. They are not necessarily zero. There are some numbers. Store that numbers. After you load, measure the numbers, compare them together. So take that initial values out. That would give you the precise current reading. And when I say precise, for every measurement, we do 100 measurements. They have to be averaged. So I'm bringing the result for you inside an Excel sheet. This is for every signal. You have something like 50 readings, 100 readings. You have to take an average of those. In Excel, that's reading. Just write a formula, average above. It takes average of the values. So that is before loading. You get that after the loading. After minus before, that gives you the strain. A strain multiplied by the Young modulus. Just Google Young modulus for aluminum. All right? And that is the stress. Now you have it. You have the experimentally measure the stress. You have the calculate the stress. And in your report, you just have to compare them. All right. Who is with me? Who is not with me? You're either with me or not with me. Can't be between. Who is between? the experimental. Okay, experimental. Okay, with the experimental, you need to know what we are going to measure. We are measuring a stress, normal stress due to the bending. Normal stress to the bending. A stress is something like a ghost. You don't see it. That is a artificial concept. It's at a very tiny point. If you could measure the force at that tiny point, and you could measure the area at that tiny area, you're able to calculate the stress. All right. So to measure it, we do that indirect measurement. We are measuring what is called elongation, percentage of elongation, or a strain. A strain, it doesn't have any unit. A strain is the elongation or shrinkage divided by initial length. That percentage value is linearly proportional to the stress. If you multiply that percentage by a coefficient, which we call that Young modulus, this is like a spring. A spring, if you have the K value and you have delta X, K times delta X, that gives you the force. So instead of measuring the force, you know the K, the constant for that spring. You know the delta X, multiplying delta X by that is how we measure the force. The very same way we do it here. But then the question becomes, okay, tell me, how am I going to measure a strain? How do we measure? There are tiny sensors we have here. These are glued to the area, and they should be small enough to capture elongation in a certain area. When you glue that, they are a resistor. A resistor, it has a continuous current going through it, and when it becomes elongated, the resistance changes. So we are measuring that change of resistance, but in the laboratory, people correlated that change of resistance to the elongation. And then, so here we know what we are measuring is a strain. And a strain, how many channels? There are 9 different readings, but the readings do not start at 0. You expect the elongation be 0, but for few reasons they are not. First of all, thermal changes. You know, the material due to the thermal changes becomes longer, shorter. So that's one reason they might have some residual strain in them. Or maybe the weight of the structure, or this has partially load applied to it. So at the beginning, it is not 0, 0, 0, 0. All 9 channels are not 0. That's okay. And then these are the continuous measurements. I mean, as we speak, they might change, right? So I make 50 readings of those over a period of the time, and those 50, if I average them, hopefully they are reliable. But then you need to average this before the loading and doing that after the loading. That way you are getting rid of the residual strain in the structure. All right. So I provide you with a software here. While you are loading it, you know how much load you are applying. The software would let you to average, remove the initial value, and now you have the measured strain. The measured strain multiplied by the Young modulus, that should give you the measured stress. The measured stress, you know how to calculate the stress and measured stress has to be compared. That's your report. Questions?
Yeah. Does the sensor give you resistance value, or does it automatically convert that resistance to?
It automatically converts. What you are reading is a percentage. You don't have to worry about the conversion. Yeah. That was the question, or yeah. Okay, you're drowsy. Good. It means you're just in between sleep and study.
So that percentage goes back to strain.
All right. So we could do this in a number of groups. How many people are we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's make this group of 3. So from this test, maybe you come here first, and you just do collected your data. Once you finish, we do the next three, and until you're finished. Do you mind if this session is being recorded? I mean, you showed on the camera. That's fine. It only will be used for educational purposes. Don't worry, I'm not gonna just send that to the TikTok. Oh, so the first thing you need is, this is a unloaded situation. The structure is not loaded. So you need an Excel file. These are how many channels? Channel 1 to channel 9, right? Channel 1 to channel 9. This is sensor 1, 2, 3, 4, 5, 6, 9. And when I click, it starts to read 100 times. So once that is finished, you have an Excel file, a matrix, 9 columns, 100 rows. So those, you store the file. That is the initial thing. You have to average them. These are the strain before the loading. And then you start releasing that weight such that the load is applied to the beam. And we do the same thing again. Make the reading, you take the file, and that's all you need to write your report. Okay, so let's get started. Keep finger crossed. Now I start that, and now this starts to do the reading 100 times. So we wait for that one to finish. You see the numbers are comparable, but not 0. Okay, which one of you is more familiar with Excel?
Probably not.
None? You?
Yeah.
Okay, I think that is connected to internet. Otherwise, I need to hotspot my own thing here. That's not a good thing because my battery is almost dead. Can anyone hotspot the mobile?
Yeah. Not hotspot.
Do you know hotspot?
Hotspot.
Yeah.
Yes, I do. Yeah.
Or if you have a USB, you can store the file on a USB. It's up to you.
That's fine. Hotspot is better.
Sorry, guys, we have a second setup, but I was single-handed. I only set up one.
So connect to the laptop.
Yeah. Yeah. So leave your mobile over there. No, not this one. Maybe just find out your
Yeah.
hotspot over there. Okay, Ahmed. Thanks. Connect. Just connect. Press first. Come here. Be comfortable. Yeah. If people want to watch, feel free to come and watch your colleagues doing this.
So it's not on load right now.
It's unloaded because the cable are loose. Yeah. And then that is still sitting on a trolley. I can just like people hang, just take the tripod underneath there. Yeah.
It's connected.
So okay, connected. So now once that 100 measurement is finished, you store that file on a desktop and email this to yourself and the rest of the team group.
Okay.
So yeah, do that now. Call this before.
Oh, there's no 100 yet.
Yeah, that's 100. I think that's 100. Yeah.
90.
Yeah, that's safe. Could be less. Even 50 is fine. Go to the desktop and save this as before, measured before. Even you can save that on your OneDrive if you wish. I mean, that's up to you. Before, save it.
Group 1?
Group 1. Save. Okay, and now I can email this to you.
Okay.
All right, let us finish. I email both of them to you. Now, to do the loading, how do you load? You want to remove the trolley or you want to tighten the screw? I mean, either way, tightening takes more time. It's safer. So it takes a few minutes. If that is tight enough, that will be released from the trolley. But you can remove the trolley underneath that.
Remove the trolley?
Yeah, carefully. So maybe we do it a little bit more tight before we release the trolley. Okay, hopefully that's same. So now this is being loaded. And if we remember the numbers, for example, one channel, the last channel reading is what? 849. Remember that? So if this could be risky. Okay, so let me close that one. And then I stop that one first and then start it again. Okay, now you see the reading for the last channel has increased, right? 800. That was 800. Once the technician left, it was almost impossible to get this one done. He took some of the files with him, and you're lucky we managed to get this working for you.
Do bridges have these sensors as well?
Sorry?
Do bridges have these sensors?
What was the sensors?
Sensors like this to make sure it's safe.
The bridge.
The bridge, the actual bridge.
Actual bridge. So these sensors are being directed to a manifold here. So the signals are being magnified first. They're being conditions. The noise is being removed, and then that is a digital analog converter. It sends all the measured data through the USB cable to the computer, and that software is a data acquisition software. So that the readings are in terms of microstrain.
The real bridge also use this kind of things.
Sorry?
The real bridge also use this kind of thing.
Bridge, if they want to measure, yes, the only way they can measure is that. I mean, the other way is you could put some markers on a specific point, and the camera is recording. If the marker moves, by that movement, this is like you've seen in the animation movies, they put marker on people's bodies to trace their motion. So you want to trace a tiny motion, could be a dedicated tripod camera sensor. But yeah, a strain gauge is very common to measure.
Yeah, it increased. Yeah, last time it was like
Yeah.
8, 4, 8, and 9, and 6. Now it's done.
Done? Okay, save this again.
You can do the controllers.
Oh, yeah. It's not right.
All right, I want you to log into your email, whatever that is, and from there, email that to yourself and the rest of the group. Maybe with your Canvas, you can do that.
From this laptop, yeah?
Yeah. Other groups, maybe you can use a OneDrive or you can use a USB drive. It's up to you.
You can mail it. You can use your email to mail it. That's good.
Well, because the groups are working together, let's get them to do it.
You can't scroll. That's not nice.
You're trying to open the mail, right?
Canvas.
Canvas.
Uh,
Yeah, go straight up.
it's numbers, it's this, so I cannot.
My email. Just scroll down a bit.
Yeah. You can't. This isn't even scroll.
Oh, there you go. Go ahead. Use this dictionary.
Yeah.
My
My
email.
email.
Okay, what a
Yes, if
glorious
you give me
day.
your
You have
email
Sehri
address.
here, Natasha here, Nuyen here, everyone almost.
So,
Aiden, Chaisal, Daniel is away. Abdullah is here, Ahmad is here, Nigel here, Barnaby away. Green is here, Shah here. Darcy, where's Darcy? Surprised Darcy didn't come.
How could I fix my profile? It still isn't showing my picture.
Sorry.
It still isn't showing my picture. How could I fix it?
Yeah. You go to the
Yes, ma'am.
student headquarters, ask them to put your picture.
you're not a student.
You know where headquarters is? HQ?
Yeah, yeah.
Excuse me, sir, the picture that you can
Someone said you can access again, should type.
Same channel,
Student.swim.edu,
I
right?
numbered and
edu.edu.
sequentially. Session 22, 23, 20. You can follow that number, yeah.
Can we do the board?
Okay. Yep. Yep.
Should I?
So that would you mind to share your data with Darcy and Daniel?
That's all.
Yeah. So,
Like,
but you have to write a lot though. Maybe. Don't. I should have done my Gmail instead. Come on.
your internet is very slow.
No.
Which company? Is it Office?
Yeah.
Office?
Yeah.
That's good.
Optus is good. Yeah, I got a.
No, Office is not good. I use Office, that's why I'm saying that.
It's good. This is Optus. Laptop is slow. It's not anything. I think Optus is better. Sorry? My brother uses Optus. I said no.
Please go.
It's taking time to speak. Yeah.
Also, you could have stored them on your OneDrive, and from OneDrive you could share with the student ID numbers.
Oh yeah. Wonder is better. No.
Were you guys here not ready?
Yes. No, I was.
So
I was.
how was it? How was it? How was it?
Because like, what? It's slow. It doesn't open.
Before the show? Well, what about this Friday? We have the demonstration.
Uh, no, it's not opening. Even separately, it's not. Just try.
That's one way of taking your destination. I mean, your destination you take the short
It's gonna
version,
deploy.
and the side one calculates the computer.
Should I try my personal
Then
one?
can you take over? Instead of
It's the
scroll.
same shit. No, Outlook is not opening.
I mean, you don't know how to scroll. Come on.
Again, this was something you
It's not opening. So should I try my personal email or no?
What happened?
It's not opening.
Uh,
Outlook
it is not opening.
No.
All right. So what you could do is you can go to your Canvas, and from Canvas you can email to anyone without things. Do you have your Canvas open?
Yeah, just scroll up.
Okay, go to Canvas, and there's an inbox. Go to the inbox. This is your inbox.
Yeah, the laptop.
You didn't click, did you?
Yes, I did. It shows inbox there.
Okay. So it seems your internet connection on mobile, the hotspot is not very.
Yeah, it's just for.
It's taking your data. Okay, now go to the right. You see that a notepad. That's to write an email. Yeah, click that one. And now just wait for the menu to complete.
Should I try giving the hotspot?
Or you can take it by Bluetooth or like hotspot. Yeah,
Could have just taken the picture of it.
you gonna type it? No, you need the file.
You need the file,
You
Excel
have to
file.
do it on the Excel. So it doesn't take the averages. You have to take it after. They were the averages, right?
I'd rather they finish before the other team starts. Otherwise,
Or else, like, can we like let everyone do, and at the end we. No, no, take that. They finish it now.
no, I mean, shouldn't take that much time.
Oh,
What browser are you using?
Optus.
What browser?
Oh, sorry. It's
Is
It's
Explorer, is
yeah,
it?
the worst one.
Or you can take it to your OneDrive as a little drive.
Can you copy that? Are you logged into your OneDrive? Go to your OneDrive.
Or you can go directly from
Yes.
Go to Swinburne page. Go to Swinburne page. That's installed to Swinburne page.
That's your page.
You guys also did the robot, right? No? That's why you go to the robot. I even sent you the code for it.
He changed his name.
Oh, you changed the name.
Sorry.
Oh.
My photos were stored on my phone.
Oh, you just asked me to go to code. I said no. You said yes, yes. Then which group was this?
Okay, from here,
Oh, okay.
log to your OneDrive. So that's the student login. So do the student login and then go to your OneDrive.
It's already logged in.
Okay, so find where the OneDrive is. So OneDrive.
You can't scroll in this for some reason.
Yeah, the path note, the right driver. You know that is crazy. I don't have the admin right to this PC, and IT is just these are the. Oh, okay. If this is the portal, OneDrive should be here, isn't it?
You can directly log in into computer to your OneDrive.
So haven't you used your OneDrive before on the portal? I mean,
Just try to log into your OneDrive directly.
Yeah, you can directly do it in like
Your site, right?
no, in computer, bro. Go on
Look at
desktop.
the
Still it's wrong.
OneDrive.
No.
sign.
The sign.
Yeah, it's gonna ask for multiple times. Sign in again.
Okay. You didn't track it.
Any progress?
It doesn't work. You should try yours.
Or take the file as a Bluetooth. It's just a 1 minute max.
tell you what, anyone has a USB phone? Done, yeah.
But or you can take with Bluetooth. It's
Do it
connected, right?
the way
Do
you
have a
can.
USB?
I have C to C cable. You
You
transfer
yeah.
the cable.
With your
Yeah,
phone?
so you just share the file with your phone.
How did it disconnect now?
Cancel it. Cancel
No,
it.
how did it disconnect all of a sudden?
Maybe there's no signal in this room.
Yeah. You don't have good news here.
Or I can connect with my hotspot. Not connected.
Unable to connect.
Some of the tissues, put it under the laptop so not everyone should bend like that. Bring this higher. Just put something underneath this one. Bring it higher.
Is it those connected?
No.
No, that's all. Is it connected?
I think 2, 3 you need.
Yours is netcom?
No. Some of my
But mine cannot connect. Yours is your phone, right? This go ahead. Let's try
Yes,
this
it
out.
is a station. Close it now, right?
Now it will work because at the time there are no internet connection. On the internet connection is now it will work. Which one is yours? Sham Mohammed.
The internet. Which
Yeah, it's so it's belong. No.
All right. So click the
Presentation. Let's see. Come on, son. I know you can. Yeah, got it. I calculated my go to the
Yeah, just by the way, I think one of the channels is not working. Maybe channel one or something. Don't be surprised. If there are nine
what's the
channels,
file name? Before and after in the desktop. Group one. Before group one and after group one. These two.
you did copy here, it copied just there, no? Oh, it copied just there, Saad.
okay. In case if you are interested,
You copied it there in the exact folder again. Just browse again. Just double tap on that one.
okay, Nigel, you want to measure the location of load. Make sure this is right in the middle. If that is not, that makes a difference. Just measure it from the middle of this one from both sides.
What are these for?
No, no, from here. The load point.
Like, do I need to measure the distance between these?
No, no, from here to there.
Sorry.
Okay, go.
Oh,
Measure it from both sides and make sure they're equal.
can you lift the wire?
I should lift it up from here. No?
No, it's that this
Oh.
Okay, good. 48. 45, 46. The wire? Yes. 49.
And from this side,
Oh my god, that's hard.
This one here. Yes.
Who are you?
45.5. 45.5.
not equal,
Not
right?
equal.
So in your calculation, take a note.
I'm not cutting it.
So your coordinate is either from here or from, I think in the shape, the coordinate system is over there. So that you note you are not loading right in the middle. That is closer to the.
So, when it elongates, this stretches, right?
Yeah.
So because
The
the
resistance-
resistance increases, right?
Yeah, yeah. Yeah, if you're designing the equipment, these are important, but for you, just those readings, you assume that the design was correct and your readings are percentage.
I was just
Yes.
asking. Sam, you did it! Yay!
Did that or no?
I guess he did it. And then I'll just move forward. Then I'll see what it goes. Just try it.
Just quickly.
I'm a try. When you do it, just push this down. I dare you. I know you can do it.
Could you have a look, please? Could you have a look, please?
Did you get the file?
Sending it.
You should have cleared the device before.
Yeah, I tried to pair. Yeah. Yeah, why? Click it here.
Do you want to use
plug the
Bluetooth?
wires.
Yeah.
All right.
The cable. Is it done? Or showing that the windows
We're
are
running out of the experiment. Just get it
Oh,
going.
it's the cable.
Okay. The most simple is the best.
Fortunately, we can't connect iPhones with that. But next generation iPhone can.
Yes. I think in Europe they already started.
Yeah, from this year onwards.
Started what
USB
we
Type.
use.
Type C cable.
Yeah, they should.
But I like the Apple one.
Yeah.
I don't know. What?
They changed the Lightning port to USB Type C.
Wow.
And that's much more firmer. Right?
It's better
It's
to
by
like
law.
just have laptops that have another option for
Well,
Type C cables.
Laptops do have this.
yeah,
There you go. Then what's the problem? We just don't have the
no,
cable.
for the iPhones.
For iPhones.
So if the charging cable for this has
No.
the end FSC type,
Not the end, the one that connects to the phone.
it should be the same. But the what? Say the USB
it's
cable
fine,
that we
then.
use to charge the
Where you can find
iPhone,
it?
we can't plug it in, right?
Just
Because
go
it's
here and
because when it's C type from the charger.
Yes,
Why are you
yeah,
talking?
yeah,
Yeah.
output next.
So there's no option over here, right?
Yeah,
for the
just
laptop.
drag those
That's
files
what I'm
in.
trying to say.
Oh,
Laptop should also have that.
what the? Okay, I will
God.
You didn't get my point.
Oh, I don't want to get your point. You didn't get mine, so very even.
You see that Saad's phone?
Yeah,
What's that you type?
I love the wallpaper.
What's the connector? Type C.
Okay.
The
Then.
same thing is going to come to iPhones as well.
Why? Why just not have one
Do you want to copy
for all
your
the
points?
types of
Yes.
cables?
Cannot copy after.
Why is there a...
Stop responding or has
Try to email it. There's no other option left. Just try to open up it on Google. Try to email it.
This computer doesn't allow to share files, I guess.
Would you hotspot yours? Maybe there was something with the.
Now it's connected directly to my phone, but now it's showing that they can't copy.
No, give the internet from another phone. Maybe his internet was...
No, now it's from my phone.
Go ahead.
Now you try to email it. Try to email the file. If the internet is working. I'm going to try to email the file now. Connect it with your...
Gmail. It doesn't give me
Doesn't
Doesn't
it
it connect to Azure? The Wi-Fi?
Wi-Fi?
It doesn't connect?
Try to connect it to the Wi-Fi, yeah.
What
Wi-Fi
happened?
Is not a problem. Now I'll show you. Could you have a look, sir?
If you try to
I'm
email,
testing
maybe you can...
Yeah. Now it's showing this one.
Yes. Click yes. All right. Let me see. Something important. Now this is connected to which network? So this is your network.
Yeah. Now it's connected with his video. final copy.
Copy.
It's already copied the series.
All right. So that is to measure. Yep.
This is really
Shah. It is you, Shah. Yeah, yeah. And that is to Ahmed. And that is to who?
Cherish.
Cherish. Who else?
Abdallah.
Who else? Is that it?
Final copy.
Okay, is that it?
Yeah.
After before.
What is this?
Okay, done.
Wow, the boss study did it in 2 minutes.
All right, next group.
Thank you, sir.
All right, can you help just unhanging the victim?
I think you need to up move a little bit. Not so good.
All good? Okay, thank you very much. Next group. All right, so what you do is now your system is
So, do you need the cable?
sure. Thank you, Rishu. All right, I'm closing this file, and now when I stop that measurement, now we can start a new one. So this new one, there is no loading here, or maybe you want to. Okay, I start, and it opens an Excel file. So this Excel file starts to make 100 readings. So you wait for that 100 to finish. There are 9 channels, 9 channels. For each channel, you have to make an average. I think one of the channels is broken. So maybe channel 1 or something. So if you find something unusual, don't be surprised. I think could be one of the channels is not. You see, before that is 850. After you load, it goes to 1,200. All right, so that's you get more signal when that is. You have to take this one away from average of this one, take away from average of the next one. Make sense? Okay. And while this is being done, you can measure the distance of this center to that load. Make sure this is in the middle. If that is not in the middle, yeah, center of this one to that line. Measure it from this side, from that side. and this is not exactly in the middle. When you are doing your calculation, you have to take note of that.
Yeah.
49, is it?
Hey, middle.
Yeah.
No, this is the middle.
49.
And from the other side?
No, I think 49. 49.
Just 49. Okay.
Yeah.
Can you do it from this side? That cable.
Oh,
See?
two.
Put zero here.
No, we can take 100 and minus.
Okay. And 45 and a half, is it?
No, it's 46.
So they're not equal.
Yeah, this one is 46.
46.
5
So
or
I
44.
think you should take that number because your
Which one?
coordinate system is over there.
This one? 49.
Your zero is over there.
Okay.
Has it been finished?
Yeah.
So save that on desktop with a name group 2 before. Group 2 before the desktop.
So what is this number? Is it the stress?
These are unloaded. These are unloaded. It's a strain.
Oh,
These
string.
numbers
Yeah.
are strain. Yeah.
Yep.
Okay. All right. Now you have to hang the victim. Just take the tripod carefully. All right. So now let me close that file and open a new file. So you save that, right? Now I stop this one, and then let's start. It starts reading. Wait for 100 to finish.
Do we have to take the average, like 100 of them, or just half?
Average of all of them.
All of them.
Each column, one average. Another average for next column, next column. So now you can see the last number is 1,200. Before that was 850.
You said that one is not working, right? So like we divide like 99 or just
Just when you do the calculation, one of the measures the stresses doesn't match with the calculation.
oh,
Whatever that is, that channel is not working.
Yeah, mixed up.
Finished? Okay, save this as group 2 after on desktop. Okay, good. Now let me email that to you. So for some reason, I'm not able to log into Eduron. Can you hotspot your and then connect to the mobile, please? Okay, good. It's connected now, is it?
Yes.
Well done. Okay. That is to Nguyen and also chase out. Chase out. Natasha. Is that you? And 40. And that is right. Okay, I think that's been said.
Thank you.
Thank you. All right, last group. Thank you for your patience. Now let's see your time. Okay, I think I need to unhang the victim. Bring that trolley, please, from here. Yeah. No, not that one. This little one.
The little one. Oh, this one.
Okay. No, that's the macro. When I press, you see, this is not loaded. When I try start, okay, it runs the Excel file, and here it captures 100 times 9 channels. One of these channel, for some reason, is disconnected. I'm not sure which one. When you do the calculation, one of the stress values should be way different.
Yeah.
So ignore that. And once this is finished, you just save that as a group 3 before,
Yeah.
and we do that after, and I email the data to you and everyone else.
Okay. So we just wait. To the district.
And then these numbers are in the order of 840, right?
Yeah.
Once you load that, it raises to 1,200. So the difference is the difference of the averages is the
Yeah. Significant. And sanitification.
Can I get one of you hotspot their mobile? For some reason, I can't log into Edge Room. I need an internet to email you the data.
Yeah.
Yeah, it is crazy. University IT has the ownership of all the stuff. I'm not the admin for this company. I'm a user,
Yeah.
and that give me lots of headaches. Can you connect to that one, please? Ignore that one. Just cancel. Find your hotspot and connect it. See? This is connected to macro. Yeah. Okay, good. Thank you. So now this is finished. Save this before group 3 on the desktop. Very slow.
Yeah.
Don't hesitate.
Take your time. No rush. Yeah.
It's not a big deal. I'm not gonna kill you.
It's really thinking. Okay. Um,
Okay, now that's good. Let's close this one and stop that macro. Now we stop the macro. Okay, now we have to hang the victim.
the victim.
Yeah, the tribal, hang him. Yeah. Screw. Now, one more thing is that load is not right in the middle of the beam.
Yeah.
If you measure it from that center to here, I think that is 49 something. See how. From center of the pin, center of the pin.
Ah,
That is
49.
40.
49 on the dot.
Yeah. From this side is different, but all you need is that number because your coordinate system is over there.
Okay.
And you know the length of the beam. You remember that number?
100 is what it's meant to be. Yeah.
You remember that length, the distance of the load from the.
Yeah. 49.
Yeah.
Yeah.
You need that for your calculation. All right, now we start the macro. Can you press start? So it calls an Excel file and it starts recording 100 times the reading.
Now it's all different.
Now this is 1,200. You see?
What's the weight?
The weight is good question. No one asked.
The lab thing says 40 kilos, I
That
think.
is, no, this is 35.5.
Okay.
Okay, everyone, no one asked, but the real weight is 35.5. So you have to multiply it by 2. You have to multiply it by 2. That's how much load you apply to the structure. So the applied load is 35.5 kilogram, and the distance of the load from the coordinate system, that was 49.5, was it? Centimeter. 49 centimeter. 49 centimeter. That's not right in the middle of the beam.
Yeah.
Okay, done. Now stop this one, and you can save that file. Now let me email that to you. Daniel Jensen. Are you Daniel Jensen? Flynn. Oh, sorry. I don't know why I get it wrong. Don't take it. Who is Daniel Jensen? He is the guy in the club. Daniel Jensen.
Oh yeah, he just never rocked up. Yeah, his name's the first. Yeah.
Flynn, and also Darcy. Did I forget anyone?
I think that's everyone.
Sorry?
Barnaby.
Barnaby. Oh, yeah. Thank you for bringing that. Barnaby. Your lifesaver. Lifesaver. Thank you very much. Okay, can I ask for a volunteer helping me to just. You're a gentleman. Thank you. Uh, just wait. I need to release this one. It's sitting there?
Yeah.
Okay, so I think that has to be. Use that plunge to bring it higher. Just use that as a lever. Lift it up.
Oh, yeah.
Under the trolley. Under the trolley, maybe it's easier.
You want to make it
Yes.
closer?
Higher, higher, higher. A bit more hard. Even more. Yep, you did it. Thank you. Now, pull that cable from underneath the table. Just pull this in. All good. All right. Now,
You're 35? No. Lie. No. No.
Ano yung may 3D print?
Get the rope and then tie your neck here.
okay. I need someone to put one hand here, hand here. One hand here, one hand here. Just
Yeah.
come with me. All right, so you have 10 days enough for writing the report. Okay, so I'm looking forward to receive your report. Any question? Next week we get into the last lectures, so then we have enough time for review. I made some review questions. We spent some, I don't know, 8 hours to do them, even more. Feel free to bring more questions. If you have any problem you want that to be solved, once we finish the lecture, we have plenty of time to go through the review sessions. All right? Thanks everyone for coming to the lab, and I look forward to see you next week if there is no question. Thank you.